You're walking under a starry Hawaiian sky. It's July 9th, 1962. It's calm, peaceful. A warm Pacific breeze whispers through the palm trees. Then, without warning, the sky erupts. A flash so intense it blinds you for a moment. The stars vanish. A strange second sun pulses above the ocean. No sound, no heat, just the sky, glowing violently. Then the power goes out. Radios stutter into silence. Streetlights flicker, then die. What just happened? That was Starfish Prime, a 1.4 megaton nuclear bomb detonated in space by the United States. It was an experiment, but not the kind you'd find in a school science lab. This was Cold War science on steroids. A test that tore a hole in the sky and rewrote the rules of war and space exploration in one blinding flash. Hey, if you're a fellow astronomy nerd or Cold War history buff, take a moment now to subscribe and hit the bell. We've got some mind-blowing stuff coming up, and trust me, you won't want to miss it. All right, let's get into it. The year is 1962. The Cold War is white hot. The US and the Soviet Union are locked in a high-stakes power struggle, not just on Earth, but above it. The space race wasn't just about rockets and flags on the moon. It was about dominance. Whoever controlled the sky controlled the future. By 1961, the Soviets had a clear lead. They launched the first satellite, Sputnik, in 1957. Then they sent the first human, Yuri Gagarin, into space. The pressure was on in Washington. The Pentagon was spooked. What if the Soviets put nuclear weapons in orbit? In response, the US launched Operation Fishbowl, a series of high-altitude nuclear tests meant to explore how space-based nukes might affect the planet. The first and most infamous of those tests? Starfish Prime. Launched from Johnston Atoll in the middle of the Pacific Ocean, a Thor rocket carried its deadly payload, a 1.4 megaton warhead, roughly 500 times the power of the bomb that destroyed Hiroshima. The target altitude, 400 kilometers, just above the boundary of space, and about where the ISS orbits today. The nuke detonated high above Earth, and what followed was surreal. Ionized particles collided with molecules in Earth's atmosphere, creating massive auroras visible across the Pacific. Even New Zealanders saw the glow. The night sky over Hawaii lit up for 6 full minutes. Streetlights across the islands failed. Radio broadcasts were knocked offline. A siren was triggered in Honolulu, sending people into panic. And yet, there was no sound, no blast wave, no mushroom cloud. That's because explosions in space are different. There's no air, no pressure wave, just a brilliant sphere of plasma, changing colors as particles ride the magnetic field lines down into the atmosphere. It was silent, beautiful, and absolutely terrifying. Scientists and military planners were eager to observe what such a detonation might do to the planet's magnetic field and to global infrastructure. And they got their answer quickly. The explosion released a wave of high-energy electrons, supercharging the Earth's magnetosphere. These particles created artificial radiation belts around the planet. So intense, they damaged or destroyed several satellites, including Ariel 1, Britain's first, and Telstar 1, the first TV broadcast satellite. And let's talk about the EMP, the electromagnetic pulse. Nuclear explosions release gamma rays that knock electrons loose from atoms. These electrons, in space, spiral along magnetic field lines and create massive electromagnetic waves. The result? A surge of electricity that can fry circuits over enormous distances. In this case, the EMP hit Hawaii, 1,500 kilometers away, and took out over 300 streetlights, disrupted phone lines, and knocked out radio signals. The implications were chilling. If a bomb in space could do that, from that far away, what could happen over a modern city, or over Europe, or the US East Coast? Let me ask you this. If a nuclear EMP hit today, in our ultra-connected, satellite-dependent world, What systems do you think would go down first? Internet, GPS, power grids? Drop your answers in the comments. I want to see what you think. Back in the 60s, Starfish Prime wasn't a one-off. It was just the beginning. Over the next 4 months, the US launched 4 more space nuke tests: Checkmate, Bluegill Triple Prime, Kingfish, and Tightrope. Checkmate went off at 147 kilometers altitude, much lower than Starfish. Kingfish detonated at 95 kilometers. And Bluegill Triple Prime, despite its cartoonish name, was deadly serious, going off at just 48 kilometers per hour. These tests gave scientists a clearer picture of how radiation interacted with Earth's layers: the mesosphere, stratosphere, and magnetosphere. And while NASA defines space as beginning at 80 kilometers, only Starfish Prime and Kingfish truly reached it. What's often forgotten is the lasting effect these explosions had. Remember the Van Allen belts? Discovered in 1958 by the Explorer 1 mission, these donut-shaped zones of radiation protect Earth from solar wind and cosmic rays. Starfish Prime overloaded them with artificial electrons, which lingered for over a decade. This radiation shredded satellite electronics and forced future missions to redesign shielding systems. It also taught us that space isn't just a silent vacuum. It's a delicate system that we can very easily mess up. Even more disturbing? Fallout. Starfish Prime released an isotope called cadmium-109, which was used to track global contamination. And yes, radioactive particles from the explosion were found in rainwater in New Zealand. That's how far the fallout traveled. Now here's a wild detail. Starfish Prime wasn't even the biggest space-adjacent nuke. That title goes to Teak, part of Operation Hardtack in 1958. That bomb? 3.88 megatons. It exploded at 76.8 kilometers, just below the official space boundary. But the blast was so strong it disrupted radio communications across the entire Pacific and turned night into day. And while the US was lighting up the sky, the Soviets weren't exactly sitting on their hands. Between 1961 and 1962, the USSR detonated 7 high-altitude nuclear weapons over Kazakhstan under a project known as K. One of them, Test 184, blew up at 290 kilometers and generated an EMP so powerful it burned down a power plant and destroyed 1,000 kilometers of buried power cables. These tests were a wake-up call. The destructive potential of EMPs, the lasting damage to satellites, the global fallout, the risk of space becoming a nuclear war zone. It all led to a rare moment of agreement between enemies. In 1963, the US, UK, and USSR signed the Limited Test Ban Treaty, which banned nuclear tests in space, the atmosphere, and underwater. And in 1967 came the Outer Space Treaty, which made it illegal to place nuclear weapons, or any WMDs in orbit or on celestial bodies. But here's the twist. These treaties have no teeth, no formal enforcement mechanisms. And today, those old fears are creeping back. In 2024, Russia vetoed a UN resolution against placing nukes in space. According to the US Department of Defense, they're developing a satellite with a nuclear payload. If launched, it could wipe out every satellite in low Earth orbit, including those controlling GPS, weather, internet, military coordination, and even farming systems. Let that sink in. One bomb, launched silently, detonated in orbit. And we're back in 1962, which brings us to now. Our civilization runs on satellites. Every text you send, every plane you fly, every forecast you check, all of it relies on space, and a single detonation could take it all offline. So the question is, are we doing enough to protect it? What do you think? Should there be new treaties? A space version of the Geneva Convention? Drop your ideas in the comments. I'd love to get a conversation going around this. Because Starfish Prime wasn't just a Cold War stunt. It was a warning. It showed us just how vulnerable we are and how powerful a weapons space could become. We can't afford to forget it. If you enjoyed this deep dive into Cold War space history, please hit that like button. It helps more than you know. And if you want to explore more stories like this, be sure to subscribe to Curiosity Echo. New videos drop weekly, and they're packed with cosmic curiosity. Oh, and here's one last question for you. If you could ask the Starfish Prime scientists one thing, anything, what would it be? Drop it in the comments, and maybe we'll feature your question in a future episode. Thanks for watching. Until next time, stay curious, stay grounded, and keep your eyes on the stars.